a lot of the time in these types of problems, you're going to have position functions. You'll start out with a position function, or maybe you won't start out with it, but usually it's denoted with S. So this is for position, and then it's in terms of time. So at a certain time, this will output where something is. If you're using like particle motion along the x-axis, then the position function, if you plug in a time value, it'll tell you where the particle is on the x-axis. So here, if you have the position function and you take the derivative with respect to time, so d dt, then you end up with the velocity function. So this tells you the velocity of the particle, or whatever you're looking at. Remember, velocity has a direction, so if you have negative, you're moving backwards or to the left. If you have a positive velocity, that's forwards or to the right. So there you go, and then if you take the derivative with respect to time of this, you end up with the acceleration function. So that's the basics for motion. Position, take the derivative, you get velocity. Velocity, take the derivative, you get acceleration. One note that I want to say is the absolute value of the velocity function. That gives you speed. So this changes to speed. And speed doesn't have a direction. It's just how fast are you going. So no direction there. So that's why you take the absolute value, because the negative or the positive means something for velocity. When you have speed, that doesn't consider any direction. So you can't if you have the speed, you don't know which way it's moving. You just know how fast it's going. So that's important. Let's take a look. Let's take a look at some things and stuff. So let's go through this. A student walks around in front of a motion detector that records her velocity at 1 second intervals. So I'm assuming that this is 1 second, another second, another, and then another. So 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds total. I guess maybe not. So for 36 seconds. So each one of these is like 4, I think, right? 4 times 9 is 36. Is it? I don't know. Yeah, so each of those tick marks represents 4 seconds. And she stores... No! Alright. She stores the data in her graphing calculator. What a nerd. And uses it to generate the time velocity graph shown in this picture. So this is a time velocity graph. Describe her motion as a function of time by reading the velocity graph. And then when is her speed maximum? Speed. Ooh, speed. So it's talking about just no direction. Alright. So this is, she stores the data in her graphing calculator and uses it. Okay, she walks in front of the motion detector and records her velocity. So this is velocity and time. So I'll write that here in the bureau. So this is the time axis, and this is the velocity axis. So it doesn't really say the units for the velocity. It doesn't say like feet per second. But we do know that this is in seconds, in 4-second intervals. Okay, let's describe what it says. Describe her motion as a function of time by reading the velocity graph. Well, since this velocity here is positive and increasing, she's moving forward and she's speeding up. Okay, that's pretty sweet. So from 0 to 4 seconds. And that's what I'm going to do. I'm going to say, okay, 0 to 4, that corresponds to that piece. From 4 to 8, that corresponds to that piece, and so on. I'm going to do it for every piece, or I'm going to try to, at least. So from 0 to 4, she's moving forward and speeding up. I know that she's speeding up because her velocity is getting bigger and bigger and bigger. Yeah. And she's moving forward. So so speeding up doesn't involve velocity. Or it does involve it, but it doesn't involve direction, I should say. Moving forward and speeding up, that just means velocity is increasing. Okay. From 4 to 8, what's happening? Well, first, she's moving forward because velocity is positive still, right? It's above the x-axis, and this is the velocity. So she's moving forward, but maintaining the constant speed. From 8 to 12, she's still moving forward because velocity is positive. It's above the x-axis, but it's getting smaller and smaller. So she's slowing down, but still moving forward. I know that she's moving forward because the velocity is still positive. Then it looks like somewhere around there she stops completely and then starts going backwards. So maybe I'll just try and describe that one point. Right when I hit record, and then the bell goes. Okay, so at approximately t equals 14 seconds, she stopped. And I just went, oh, okay, this is 4, this is 8, this is 12, 13, maybe it's 14. So it's approximate. She is stopped. And then from approximately 14 to, I'm just going to say to that one, what is that? About 20. So I'm going to say approximately from 14 to 20, she is speeding up, right? Because her velocity is getting more and more, I guess, farther away from the x-axis. It's increasing, but it's negative, so it's actually decreasing. But it's the absolute value of it is getting bigger and bigger and bigger, right? This is a very large negative number. So she's speeding up, but she's going backwards. And I know that because the velocity is below the x-axis, which means the velocity is negative. But it's getting like more and more negative, which means she's speeding up. This is the part that confuses most people, just because you would think, wait a minute, it's going down and down and down and down. Yes, velocity is decreasing, but if we take the absolute value of this, it would change this to look like that. It would reflect this over the x-axis. So then you would say, oh yeah, look, it is speeding up. So there you go. The speed is increasing, the velocity is decreasing. Because the speed is just the absolute value of the velocity. All right, let's continue on. From 20 to, that was what, 24, 25, 26 about. She is still going backwards because the velocity is negative. However, her velocity is getting closer and closer to 0. So she's slowing down. Hopefully that makes sense. I'm taking a lot of time to explain this because I think you might even need to rewatch it just because it is a little bit confusing. And then it looks like from 26 to, what is that, 32? Her velocity is 0. And it stays 0 for a while. So she's stopped, completely stopped for that interval. So over here, when it just crossed the x-axis, she stopped for an instant and then went backwards. I mean, you can't go forward and then move backward without stopping at some instant. No matter how small it is, it's still stopped for an instant. And then on this interval, she stopped for a while, and that's why we see 0 velocity for a few seconds. And then after that, it's the same as this, it looks like. So she's moving forward and speeding up. That was quite lengthy. Hopefully it makes sense though. You're reading the graph. Note that when velocity is negative, you're moving backwards. When velocity is positive, you're moving forwards. However, in either case, you could be speeding up or slowing down. So maybe you can think of the absolute value of the velocity, and if that's increasing or decreasing, then you're speeding up or slowing down accordingly. Or you can think of it as, well, if I'm talking about speed, then I'm speeding up as I'm getting farther away from the x-axis. That's literally what's happening. As if you get farther away from the x-axis, you're speeding up. If you're getting closer to the x-axis, you're slowing down. Now it's different for velocity, because if you just have a negative slope for velocity, velocity is decreasing. However, here we're slowing down, here we're speeding up, just because of what I said before. If you're getting closer to the x-axis, you're slowing down. If you're getting farther away from the x-axis, you're speeding up. Okay, I'm done with this video.